This is the example video for graphing absolute value equations. Let's take a look at the first one. We've got y equals the absolute value of x plus 3. Okay, so first I'll find my vertex. So I've got my x-coordinate and my y-coordinate. So to find the vertex, if you remember, taking a look back at the notes, I'll take whatever is inside the bars, so I've got x plus 3 here, and set it equal to 0. So x plus 3 equals 0. Now I'll just solve for x. So I'll subtract 3 from both sides. When I do this, 3 minus 3 cancels. I get x equals negative 3. So I'll take this negative 3 and I'll plug it in for my x-coordinate. Now to find my y-coordinate, I will take this negative 3 and plug it into my original given equation. So I've got y equals the absolute value, instead of x I'm plugging in negative 3, plus 3. Negative 3 plus 3 is 0, so I get y equals the absolute value of 0. And I know 0 is 0 units away from 0 on the number line, so I know y is going to be 0. So my vertex is going to be the point negative 3, 0. So I'll start creating my table of values down here. I've got x and I've got y. I'll plug the vertex right into the middle, negative 3, 0. And I'll pick two integer values for x to plug into my table that are immediately to the left and immediately to the right. So to the left of negative 3, I have negative 4 and negative 5. And to the right, I have negative 2 and I have negative 1. So now I'll take these inputs, or these x-coordinates, and plug them into my original given equation to find my y-coordinates, or my outputs. So I'll do that right over here. So I've got y equals the absolute value of negative 5 plus 3. I'm just starting at the top and making my way down. So I know negative 5 plus 3 is going to be negative 2. And the absolute value of negative 2 will be 2. So I'll take this 2 and I'll plug it in next to my 5. So my input was negative 5, my output was 2. So now I'll do negative 4. Okay, negative 4 plus 3 is going to be negative 1. And the absolute value of negative 1 is 1, because negative 1 is 1 unit away from 0 on the number line. So I'll take that 1 and plug it in here. I already have my next point, my vertex, so I'll move on to negative 2. So I have y equals the absolute value of negative 2 plus 3. Negative 2 plus 3 is going to be 1, so we have y equals the absolute value of 1. And the absolute value of 1, of course, is 1. Last one, we've got y equals the absolute value of negative 1 plus 3. So when we do that, we get y equals the absolute value of 2, which we know is 2. Okay, so we found the vertex, picked two integer values to the left of our vertex and to the right of our vertex. Okay, took those x-coordinates, or our inputs, as we like to call them, plugged them into our original given equation, and got these outputs. So now we've got all these ordered pairs that we can graph. So we've got negative 5, 2. We've got negative 4, 1. Negative 3, 0. Negative 2, 1. And negative 1, 2. Now we can just connect. Okay, and when doing these, I would like you to find 5 points, including the vertex. So this is what our graphed absolute value equation would look like. Okay, pause if you need more time. So for this one, I have y equals the absolute value of x minus 4. So I will find my vertex. Where x is first, followed by y. So I'll start by finding my x coordinate for my vertex. So I'm taking whatever's inside the bars. So I've got x here, and setting it equal to 0. And now we have to get x by itself. Well, this one works out pretty nice for us because x is already by itself. So we're going to take this 0 and plug it in for our x coordinate. So to find our y coordinate, we're going to take our original given equation and plug in our x coordinate for x. So we've got y equals the absolute value, used to be x, now it's a 0, minus 4. So the absolute value of 0 is going to be 0. And then we've got minus 4. So y is going to be negative 4. And just like that, we have our vertex. So now I will make my table of values. Plug in my vertex right in the middle. And pick 2 integer values to the left of my vertex and to the right. So to the left I have negative 1, negative 2, and to the right I have 1 and 2. So I'll start by plugging in negative 2 into my original given equation. So I've got y equals the absolute value of negative 2 minus 4. The absolute value of negative 2 is going to be 2, so I've got y equals 2 minus 4, because negative 2 is 2 units away from 0 on the number line, and 2 minus 4 is negative 2. So I'll take this negative 2 and I'll plug it in next to this negative 2 down here. Moving on to the next one, I've got y equals the absolute value of negative 1 minus 4. The absolute value of negative 1 is 1. And 1 minus 4 is negative 3. Okay, vertex is already done, so we'll move on to 1. We have y equals the absolute value of 1 minus 4. Absolute value of 1 is 1, so we have y equals 1 minus 4. And 1 minus 4, of course, is negative 3. Last one, plug in 2, so we've got y equals the absolute value of 2 minus 4. Absolute value of 2 is 2, so we have y equals 2 minus 4, which is negative 2. So now we can plug all these points in. So I'll plug in my vertex 0, negative 4, negative 1, negative 3, so negative 1, negative 3, negative 2, negative 2, and we have 1, negative 3, and 2, negative 2. And then I'll add some arrows just to show that these go on forever. So that is our graphed absolute value equation. So the next two I'm going to graph using our axis of symmetry method. Okay, saving us a little bit of work. Okay, pause if you need more time. Okay, so we have y equals the absolute value of x minus 2 plus 3. So first I'll find my vertex. This process won't change. So to get my x coordinate, I'll take whatever is in between the bars, so in this case x minus 2, and set it equal to 0. So to get the x by itself, I'll add 2 to both sides. When I do that, negative 2 plus 2 cancels, so we get x equals 0 plus 2, which is 2. So we'll take that 2 and plug it in for my x coordinate. So to solve for my y coordinate, I'll take that 2 and plug it in for x in the original equation. So we have y equals the absolute value of 2 minus 2 plus 3. 2 minus 2, of course, is 0, so we get y equals the absolute value of 0 plus 3. The absolute value of 0 is 0, so we get y equals 0 plus 3, which is 3. So I'll take that 3 and I'll plug it in for my y coordinate. So again, I'll make my table of values, x, y. When I do that, I'll plug in my vertex right in the middle, so 2, 3, and I'll pick the rest of my x coordinates. So immediately to the left, we've got 1 and 0, and to the right, we have 3 and 4. Okay, so I'll plug in 0 first. So we've got y equals the absolute value of 0 minus 2 plus 3. 0 minus 2 is negative 2. So we've got the absolute value of negative 2 plus 3. Absolute value of negative 2 is going to be 2. And then when we add 3, we get 5. So when I plug in 0, I know I get 5. So since I found my vertex to start off using my axis of symmetry method, because 0 is 2 units away from 2 on the number line, and 4 is also 2 units away from 2 on the number line, I know that when I plug in 4 into this absolute value equation, I will also get 5. Okay? Definitely allowed to do that. Okay? So now I'll plug in 1, and when I plug in 1, I get y equals the absolute value of 1 minus 2 plus 3. 1 minus 2 is going to be negative 1 plus 3. And the absolute value of negative 1 is 1. So we get y equals 1 plus 3, which we know is 4. So when we plug in 1, we get 4, which also means, using the axis of symmetry method, that when we plug in 3, we'll also get 4. So when we plug all these points in, we get 0, 5, 1, 4, 2, 3, 3, 4, and 4, 5. And of course, we can finish it off by connecting these points and adding some arrows. And there we have it. Pause the video if you need more time. Okay, for number 4, I'm going to use the axis of symmetry method again. So for our vertex, we define what our x coordinate and y coordinates are. So to find my x coordinate, I'll take x plus 1 and set it equal to 0. To solve for x, I'll subtract 1 from both sides. When I do that, 1 minus 1 cancels, so we get x equals negative 1. take that negative 1 and I'll plug it in for x up here. Now to find y, I'll plug in negative 1 for x. So y equals negative absolute value of negative 1 plus 1 minus 4. So negative 1 plus 1 is going to be 0, so we have y equals negative absolute value of 0 minus 4. So we're going to get y equals negative 0 minus 4. Well, negative 0 is just 0, so y will be negative 4. Sorry about that, had to get a little bit of power, didn't want to run out. So I'll make my table of values. So we have x, we have y. I'll plug my vertex right in the middle, so we have negative 1, negative 4. Two values to the left are going to be negative 2 and negative 3. And two to the right are going to be 0 and 1. Okay? So because my vertex is right in the middle and I plug values that are, or x coordinates that are equidistant from the x coordinate of my vertex into this table of values, I can use the axis of symmetry method. Okay? So I'll plug in 0 and 1 just because I think that'll be easier math for me than plugging in negative 3 and negative 2. Maybe less of a chance of making a mistake. So when I plug in 0, I get y equals negative absolute value of 0 plus 1 minus 4. So 0 plus 1 is obviously going to be 1. Okay, so absolute value of 1 I know is going to be 1, but we also have to drop down this negative sign. So all of a sudden I have negative 1 minus 4 for y, and negative 1 minus 4 is going to be negative 5. Okay, which also means when I plug in negative 2, I'll also get negative 5. Because negative 2 and 0 are the same distance away from negative 1. Okay, they're both 1 unit away. Okay, so now I'll plug in 1. So I have y equals negative absolute value of 1 plus 1 minus 4. 1 plus 1 is going to be 2. But I also have to drop down the negative sign. Negative 2 minus 4 is negative 6, so we get y equals negative 6. So when I plug in 1, I got negative 6, which means when I plug in negative 3, I'll also get negative 6. And if you want to try that out, by all means, go right ahead. So now I'm just plugging in these points. I've got negative 1, negative 4, negative 2, negative 5, negative 3, negative 6. And then I've got 0, negative 5, and 1, negative 6. To finish this off, I'll connect my points. I know I've done this right because it looks like a V. If it does not look like a V, you might want to go back and check your math. Okay. So there we have it. At this point, I would move on to the example sheet for graphing absolute value equations.